Hey people, this video is going to talk about exact values. Oh boy, the phone is ringing. Okay folks, this video is going to be about exact values and an introduction to two special triangles, and they are very special. So first of all, let's talk about exact values. I guess on the screen in front of you, you can see pi, you can see the square root of 2, and you can see tan 30. Okay, so you can see, you can see these three things. Let's start with pi though. Pi is a symbol, and usually if I ask students what is pi, they'll tell me 3.14. And there might be the odd student that'll tell me more decimals. They'll be like, well, actually it's 3.14159, and it just keeps going on and on. A lot of calculators have pi built into them, and you can see how long it goes. It just keeps going. In fact, it goes forever. So when we're saying 3.14, what we're doing is really just rounding that off. Now, an exact value is something that's not rounded off. It's exact. Whereas 3.14 is actually what we would call an approximation. It's a close approximation to the exact value that is pi. But we just don't have time or the patience to write down what pi is. In fact, I've heard that pi goes on forever, so we definitely don't want to write the entire thing. So yeah, so pi is just an exact value. This symbol is an exact value, okay? What we write down as 3.14 is not. It's just not as accurate as the actual symbol for pi. Here we have the square root of 2, okay? I don't know why I'm doing this, but just doing it while I talk. By the way, the square root of 2, take a calculator. Let's find the square root of 2. Look at that. And I believe it just keeps going on and on. It might not. I actually don't know. You'd think I would know, but I don't. However, I see a lot of decimals there. So I would just round it off to like something like 1.41, okay? 1.41. But again, it's the same deal as with pi. This is just an approximation, whereas this is an exact value. It's a symbol saying the square root of 2. Okay, that is an exact value. Tangent 30. Let's check that one out on the calculator. 30. Make sure your calculator's in degree mode if you're doing this at home. It's the same deal, okay? 0.577 or something like that. 0.577. This is an approximation of an exact value, which tan 30 is. Tan 30 is an exact value. 0.577 is just a number that is very, very close to this. It's just we rounded this one off. Have I made my point clear? I think I have. I'm going to stop talking about exact values with regards to this. I'm going to move to the next page. Okay, so over here are two special triangles, and these are really useful triangles. In fact, some teachers ask their students to memorize them because they come into play quite a bit when we're in these parts of trigonometry, such as we're in now. Okay. A better explanation about these triangles would be to see how they came about. And in the booklet that I give my students, it shows how they came up with these triangles. But for now, just for the sake of time, I'm just going to talk about how to use these two triangles, okay? I'm just going to show you how they work. Let's say we're standing right here at the 30 degrees, and we look across, and then we look at the hypotenuse, okay? Well, remember, opposite and the hypotenuse is sine, okay? And this would be for 30 degrees. And if we took our calculator and we typed in the sine of 30 degrees, make sure it's in degree mode, you get 0.5. Does that make sense? Well, look what we have here. The sine of 30 is 1 over 2. It really works, okay? If we were to say the, the tangent of 60, on our calculator, this is going to be a long decimal, I believe. There it is. It's a very long decimal. But if we didn't want to have that, long decimal, you would look at this and say tangent of 60 is opposite over adjacent, root 3 over 1. or just root 3 because the 1 on the bottom doesn't really matter, okay? Anything divided by 1 is still that same thing. So tan 60 is equal to root 3. This is an exact value, and that's what we were talking about on the other page. When your teacher asks you on a test or a quiz for an exact value, you're going to keep things like this rather than give them a long decimal like the calculator gave me here, 1.73205, blah, blah, blah. Okay? If they're asking for an exact value, you just write it like this with the symbol square root 3 right here. Okay? If we look over to this triangle over here, it's called the 45, 45, 90 triangle, and it has special ratios too, so that if you were saying, let's just say, if you were asking for the tangent of 45, well, you look on this triangle here, it doesn't matter which one you stand at. If you're standing here, opposite and adjacent is 1 over 1. So the tangent of 45 must be 1. Let's check it out to verify. It is, okay? That's an exact value. It's quite nice. But what if we were asking, what is the sine of 45 degrees? Well, if we looked at the special triangle right here, we would say sine is opposite over hypotenuse. That'd be 1 over root 2. No matter which 45 you stand at, you're going to get 1 over root 2. And if they're saying what's the exact value, then you would stop right there. If you don't want the exact value, just use your calculator and type in the sine of 45, which is this crazy number right here. Just for fun, let's see if we get this same decimal. If we were to go, if sine 45 apparently equals 1 divided by the square root of 2, let's see if we get 0.707. I'm going to write that down. Shoot, I already forgot. 707 was it? And then it continued on. But anyway, let's just see if we get that on our calculator. 1 divided by the square root of 2 is equal to, look at that. You get the exact same thing. It's pretty cool, eh? These special triangles are very useful and you're going to have to use something like this. There are different techniques whenever your teacher says, I want exact values. Okay? That is your clue immediately to start memorizing these two little triangles and quickly writing them down on your test or quiz at the top so that you're able to have that with you. We've been talking about, prior to this lesson, about angles that are like this, starting at 0 degrees and moving around like this, and they're called angles in standard position, usually between 0 and 360 degrees. There's also something that we've talked about called the related acute angle, which is the angle between the x-axis and this thing called the terminal arm. If all of this is gibberish, definitely watch those videos, the ones that talk about angles in standard position, okay? When you get an angle of 30 degrees in here, for example, and if they say exact values, then you're going to use this triangle. If this angle in here is 45, and they say we want the exact values, then you're going to use this triangle. If you're back here and this angle happens to be 60 degrees, you're going to go back and use this triangle and start from the 60 degrees right here. Now that may have just confused you, so let's look at some questions that actually ask us those kinds of things. Our handy dandy two triangles are right here and here. Here's the 45, 45, 90. Here's the 30, 60, 90 triangles. And let's use them to solve this situation. What is the exact value, ding, 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 write those down, of tan 30? Tangent of 30. There we go. There's our 30 degrees right there. Again, hopefully you've watched those videos on the angles in standard position, because what I'm doing now is creating a little right angle triangle out of this. As soon as you have 30 right here, we know that we need this triangle right here. We do not need this triangle for this question. Okay? Now this is a 30, 60, 90 triangle. And then immediately you have to remember by memorizing what is across from the 30. Well, there's 1. Over here, the hypotenuse being the longest side is 2, and over here will be root 3. Notice how I just placed them according to what I saw here in this special triangle. You just place them on here, and then you say to yourself, what's the exact value of tan 30? Well, the exact value of tan 30 is, start here, opposite over adjacent, 1 over the square root of 3. Okay? The last thing you have to think about, this is the last thing you have to think about on a question like this, is this answer going to be positive or negative? And that's when you have to go back and remember the CAST rule. Again, that's a video that comes before this one, so I really hope you're watching them in some kind of order, or that you know this already. In this quadrant right here, sine, cosine, and tangent are all positive. Okay? The other quadrant that tangent is positive in is this third quadrant down here where the t is. Okay? And if you had to, you could come up with another answer besides tan 30 that would give you 1 over root 3. But in this video, they're not asking that. We're just finding out what's the exact value of tan 30. Okay? There is another video that I have that says how to find two angles in standard position that will give you the same trig ratio, like that 1 over root 3, okay? And I shouldn't get into it as tempting as that is right now. I should stop and stay on focus, on track. I'm going to go to the next question. What is the exact value of cosine of cos 60? Okay, so you quickly draw that. 60 degrees looks something like that. Okay, draw your triangle with a little 90 degrees there. Which triangle are we going to be using? It's one of these two special triangles. The cool thing is your questions when it comes to exact value, almost always there will be in the related acute angle, either here or in this quadrant or this quadrant, the related acute angle will always be either 45, 60, or 30. So how would you draw this one over here? Well, it's this triangle again. It's not the 45, 45, 90. Sorry, I don't think there's any example after this. There's no example that I have on this video that uses this, but it's the same technique no matter how you do it. You use the triangle you need, and you write in everything else. So the 30 goes there. What's across from the 30? What's opposite? The 1. The 2 is the longest side, and the root 3 is across or opposite the 60 degrees. Then from here, we say cos 60 is equal to, now cosine is adjacent over the hypotenuse, 1/2. Okay? And there it is. Now remember, you would ask yourself again, is this positive in this quadrant? And the answer is yes. 60 degrees is for cosine is positive in this quadrant. It would have been good. Oh, I see. Look at the bottom. The next lesson will show how to find exact values of angles greater than 90 degrees. So what we'll do is we'll do that on the next video. For now, we're going to stick to what we just saw. You've seen it here first, folks. Have a good day.